Okay, we're going to try we're still going to do the network fundamentals. And this time we're going to go Intro to LAN. Learn about some of the techniques and designs that powered private networks. Intro to LAN. TryHackMe has a great video on YouTube. You should go check it out. Always support their products. Introducing LAN topologies. Local area networks, LAN topologies. Over the years, there have been experimentation and implementation of various network designs. In reference to networking, when we refer to the term topology, we are actually referring to the design or the look of the network at hand. Let's discuss the advantages and disadvantages of each topology below. Star topology. The main premise of a star topology is that devices are individually connected via a central networking device, such as a switch or a hub. This topology is the most commonly found today because of its reliability and scalability, despite the cost. Any information sent to a device in this topology is sent via a central device to which it connects. Let's explore some of the advantages and disadvantages of this topology below. Because more cabling and the purchase of dedicated networking equipment is required for this topology, it is the most expensive of any other topologies. However, despite the added cost, this does provide some significant advantages. For example, this topology is much more scalable in nature, which means that it's very easy to add more devices as demand for the network increases. Unfortunately, the more the network scales, the more maintenance is required to keep the network functional. This increased dependence on maintenance can also make troubleshooting faults much harder. Furthermore, the star topology is still prone to failure, at reduced. For example, if the centralized hardware that connects devices fails, these devices will no longer be able to send or receive data. Thankfully, these centralized hardware devices are often robust. As you see here, this is a star topology. The hub connects many computers. Bus topology. This type of connection relies on a single connection, which is known as a backbone cable. This type of topology is similar to a leaf off a tree in the sense that devices, leaves, stem from where the branches are on the cable. Because all data destined for each device travels along the same cable, it very quickly is prone to becoming slow and bottlenecked if devices within the topology are simultaneously requesting data. The bottlenecks also result in a very difficult troubleshooting because it quickly becomes difficult to identify which device is experiencing issues with data, all traveling along the same route. However, with this being said, bus topologies are one of the easier and more cost-efficient topologies to set up because of their expenses, such as cabling or a dedicated networking equipment used to connect these devices. Lastly, another disadvantage of the bus topology is that there is little redundancy in place for cause of failures. This disadvantage is because there's a simple point of failure along the backbone cable. If this cable were to break, devices can no longer receive or transmit data along the bus. Ring topology. The ring topology is also known as token topology. Boasts some similarities. These devices, such as computers, are connected directly to each other to form a loop, meaning that there is a little cabling required and less dependence on dedicated hardware such as within the star. Devices such as computers are connected directly to each other to form a loop, meaning that there is little cabling required and less dependence on dedicated hardware such as within a star topology. A ring topology works by sending data across the loop until it reaches the designated device, using other devices along the loop to forward data. Interestingly, a device will only receive data from another device in this topology if it does not have any to send itself. If a device happens to have data to send, it will send its own data first before sending the data from another device. Because there is only one direction for the data to travel across this topology, it is fairly easy to troubleshoot any faults that may arise. However, this is a double-edged sword, because it isn't an effective way of data traveling across the network, as it may have to visit multiple devices first before reaching the intended device. Lastly, ring topologies are less prone to bottlenecks, such as within a bus topology, a large amounts of traffic are not traveling across the network at one time. The design of this topology does, however, mean the fault of such a cut cable or a broken device will result in the entire network breaking. What is a switch? Switches are dedicated devices within a network that are designed to aggregate multiple other devices such as computers, printers, or other networking capable device using Ethernet. Switches are usually found in larger networks such as business, schools, or similar sized networks where there are many devices to connect to a network. Switches can connect a large number of devices by having ports of 4, 8, 16, 24, 32, and 64 for devices to plug into. Switches are more efficient than their lesser counterpart, the hubs or repeaters. Switches keep track of what device is connected to which port. This way, when you receive a packet, instead of repeating that packet to every port like a hub would do, it sends it to the intended target, thus reducing network traffic. The internet to router 1, and it goes to 2 switches in your business. Also, basically switches are also good for home use too. I do have a couple, just to play with. Both switches and routers can be connected to one another. The ability to do this increases the redundancy, the reliability, of a network by adding multiple paths for data to take. If one path goes down, the other can be used. While this may reduce the overall performance of a network because packets have to take longer to travel, there is no downtime, a small price to pay considering the alternative. What is a router? It's a router's job to connect networks and pass data between them. It does this by using routing, hence the name of the router. Routing is the label given to the process of data traveling across the networks. Routing involves creating a path between networks so that this data can be successfully delivered. Routing is useful when devices are connected by many paths, such as the example diagram below. Okay, practical. Attached to this task is an interactive practical featuring the discussed LAN topologies to learn about various ways in which we are vulnerable to breaking. Break the LAN topologies to receive the flag. All right, time to start answering some questions. Now the first one, what does LAN stand for? Should be local area network. What verb is given to the job that routers perform? Routing. What device is used to centrally connect multiple devices on a local network and transmit data to the correct location? Should be a switch. What topology is the cost efficient to set up? Which is a bus technology or bus topology? What topology is expensive to set up and maintain? The star topology. All right. Complete the interactive lab attached to this task, and the flag will be given at the end. Okay, let's see where this is here. Go up to the top. Visit view site. Topology flaws. This lab will take you through the flaws of different network topologies. In a ring topology, all devices are connected to 2 others to create a full circle. Packets of data travel from one device to the next until they reach their destination. One of the major flaws with a ring topology is that if a device goes down or a cable is broken, then the data will no longer be passed. If you hover over the middle of the network cable, you can cut it and see what happens to the packets. All right, let's check. Ooh, cut it. Whoa, broke it. It looks broken. The packets can now no longer travel around the network, and no device can talk to each other. Bus topology. With a bus topology, all devices are connected to a single cable, often called the backbone. Data is sent in both left and right directions down the backbone until the packet destination is reached. A major flaw in the bus topology is that it can't handle a large amount of data. On the next step, send as many packets as quickly as you can to try to take down the network. Computer 1 to computer 1. Computer 1, 4. Send packet. I'm going to go to computer 5. Where's computer 5 at? it's a packet storm. Okay, the bus network is now down. That was a lot of clicking. Star topology. With a star topology, all the devices are connected with their own cable to a central hub or switch. Every packet is sent through the switch, which means that the switch goes down, the network will no longer work. See if you can break the switch. That was easy. The network is down. I guarantee you take a hammer or anything, the network will go down. All right, there's our topology right here. TMH topology. All right, start it again. Completed. We found all the flaws. Copy this. Copy. Take that down. All right. What I wanted to do is show you my notes. I know that I'm big on note taking. The more you take notes, the more you'll memorize it, and the more you'll learn the material. As you can see here, I started off with, the first thing with the star topology. I went through and I did some research online also and found out, what the advantages are and what the disadvantages are. It's a little bit more of a thorough introduction than a normal Try Me class. As you see here, here's the bus topology, the advantages and the disadvantages. And same with the ring. Now, as you go down, you'll see, I know that in the Try Me we had a switch and a router, 2 different categories and 2 different subjects they were doing. And I just decided to make it into one. It's a lot easier that way because I already know what a switch is. I already know what a router is. If you don't, you need to go back and actually learn that too, because the equipment is a good, I don't want to say this, the equipment that you use, you need to know. A primer on subnetting. As we previously discussed throughout the module so far, networks can be found in all shapes and sizes, ranging from small to large. Subnetting is a term given to the splitting of a network into smaller, miniature networks within itself. Think of it as slicing up a cake for your friends. There's only a certain amount of cake that can go around, but everybody wants a piece. Subnetting is you deciding who gets what slice and reserving such a slice in this metaphorical cake. Take a business, for example. You'll have different departments such as finance, accounting, human resources. So when you see the internet, it goes to the router, then the switch, then you have your 3 departments. Whilst you know where to send the information in real life to the correct department, networks need to know as well. Network administrators are using subnetting to categorize and assign specific parts of the network to reflect this. Subnetting is achieved by splitting up the number of hosts that can fit within the network, represented by the number called subnet mask. Let's refer back to our diagram from the first room of the module. Octet 1 is 192, Octet 2 is 168, Octet 3 is 1, Octet 4 is 1. As we recall, an IP address is made up of 4 sections called octets, the same number of a subnet mask, which is also represented by the number of 4 bytes, 32 bits, ranging from 0 to 255. Subnets used IP addresses in 3 different ways: identify the network address, identify the host address, and identify the default gateway. Let's split these 3 up to understand their purposes into the tables below. The network address. The address identifies the start of an actual network and is used to identify the network's existence. For example, a device with an IP address of 192.168.1.100 will be on the same network identified as 192.168.1.0. The host address. An IP address here is used to identify the device on the subnet. For example, the device will have a network address of 192.168.1.1. Default gateway address is a special address assigned to a device on the network that is capable of sending information to another network. Any data that needs to go to a device that isn't on the same network, i.e. that's not on 192.168.1.0, will be sent to this device. These devices can use any host address, but usually use either the first or last host address in a network, a 0.1 or a 0.254. Now, in small networks, such as at home, you will be on one subnet, as there is an unlikely chance that you need more than 254 devices connected at one time. However, places such as businesses and offices will have much more of these devices, PCs, printers, cameras, sensors, where subnetting takes place. Subnetting provides a range of benefits, including efficiency, security, and full control. We'll come on to explore exactly how subnetting provides these benefits at a later date. However, for now, all we need to understand is the security element to it. Let's take a typical cafe on the street. This cafe will have two networks, one for employees, cash registers, and other devices at the facility, one for the general public to use as a hotspot. Subnetting allows you to separate these two use cases from each other while having the benefits of a connection to a larger network such as the internet. All right, let's answer the questions below. What is the technical term for dividing a network up into smaller pieces? Subnetting. How many bits are in a subnet mask? 32, right? What is the range of a section octet of a subnet mask? All right, 0 to 255. What address is used to identify the start of a network? All right, I think it's a network address. What address is used to identify the device within the network? Probably a host. What is the name used to identify the device responsible for sending data to another network? That would be the default gateway. Here's my notes and primer of subnetting. Now you're going to need to learn how to do subnetting. It's a pain in the ass, but once you get it down, you'll know it. There's a lot of people that do not know how to do subnetting, and it's kind of crazy, but it's one of the skills that you will need to know. As you see here, there's a chart, and it gives you some good information on how to do subnetting. And in future videos, we will go deeper into this. And here's a full reference chart. And then here's our questions. And here's the links. I will be adding the links down below too. But these are perfect tools to put in your notes in case you need them. And here's a full reference. The ARP protocol. Recalling from previous tasks that devices can have two identifiers, a MAC address and an IP address. The Address Resolution Protocol, or the ARP protocol for short, is a technology that is responsible for allowing devices to identify themselves on a network. Simply, the ARP protocol allows a device to associate its MAC address with an IP address on the network. Each device on a network will keep a log of the MAC address associated with other devices. When protocols wish to communicate with each other, they send a broadcast to the entire network searching for a specific device. Devices can use the ARP protocol to find the MAC addresses, and therefore the physical identifier of a device for communications. How does ARP work? Each device within a network has a ledger to store information on, which is called cache. In the context of the ARP protocol, this cache stores the identifiers of all other devices on the network. And in order to map these two identifiers together, the IP address and the MAC address, the ARP protocol sends two types of messages. One is an ARP request, and two is the ARP relay. When an ARP request is sent, a message is broadcasted to every other device found on the network by the device, asking whether or not matches a requested IP address. If the device does have the requested IP address, the ARP relay is returned to the initial device to acknowledge this. The initial device will now remember this and store it within its cache as an ARP entry. This process is illustrated in the diagram below. 1. The SRC MAC and the destination MAC. Message. Who has IP address 192.168.1.10? And it sends it out. There's one device that has it, and it sends it back, the SRP, the destination MAC, and the message, I have the address 192.168.1.10. All right, time for the questions. What is ARP? Address Resolution Protocol. What category of an ARP packet asks a device whether or not it has a specific address request. What address is used as a physical identifier for a device on a network? I do believe that's a MAC address. What address is used as a logical identifier for a device on a network? An IP address. Oops. An IP address. All right, let's take a look at my notes. As you can see here, I pulled out a diagram to help me understand what an ARP request and ARP reply looks like. The DHCP protocol. IP addresses can be assigned by either manually, by entering them physically into a device, or automatically and most commonly used by using DHCP server, which is a dynamic host configuration protocol. When a device connects to a network, if it has not already been manually assigned an IP address, it sends out a request, a DHCP discover, to see if any DHCP servers are on the network. The DHCP server then replies back with an IP address the device could use, the DHCP offer. The device then sends a reply confirming that it wants the offered IP address, a DHCP request. Then lastly, the DHCP server sends a reply acknowledging this has been completed, and the device can start using the IP address, the DHCP acknowledge, ACK. So here's the DHCP discover. Hey, I'm new here. Is there anyone who can give me an IP address? The DHCP offer. Sure thing. You can have 192.168.1.10. The DHCP request. Yes, that would be brilliant. I'll start using 198.168.1.10. Then they acknowledge, the DHCP acknowledge. Okay, great. You can use that IP address for the next 24 hours. All right, on to the questions. Answer the questions below. What type of DHCP packet is used to advise to retrieve an IP address? DHCP. What type of DHCP packet does a device send once it has been offered an IP address by the DHCP server? Sure, it's right there on the board, right? And final, what is the last DHCP packet that is sent to a device from a DHCP server, which would be the acknowledge. There we go. All right, looks like we are done with the other one. Looks like we are done with this module. We'll continue with the OSI model room, and that's going to be a fun one. All right, here are my notes for the DHCP protocol. I found an image online that I liked, so I tossed it in my notes.